Hello and welcome to step 3, part 2, where we're going to talk all things three-dimensional figures. So we're going to take those two-dimensional figures that we talked about in part 1 and actually assemble them to create three-dimensional figures, okay? So if we have a nice three-dimensional figure that you've seen before, where all the faces are actual solid polygons. We call this a polyhedron. Okay, that definition works similar to what a polygon is. Okay, and then the pieces, the shapes that we're actually putting together are what we call the faces. Okay, we have edges where the two faces meet. And then the corners, those official names are called the vertex. We're also going to get into an example of this. So that's just a nice visual for us now. Okay, so when we have polyhedrons, there's different ways that we can actually name them, okay? So the two main types of polyhedrons are prisms and pyramids. So prisms have bases. So like for this example, the base here is the non-rectangle piece. It's this pentagon at the top and the bottom. Okay, your bases will not always be the top and the bottom, but the bases will be, if there are pieces that are not rectangles, those are going to be your bases. So this would be called, a pentagonal prism because it has a pentagon base, and we know it's a prism because those two bases are connected by a bunch of rectangles. Pyramids, on the other hand, they can have a triangular base, but sometimes they don't. The base would be the non-triangle piece, but if they're all triangles, then it's a triangle. The non-triangle piece, and then all the triangles come up to a point at the very top. So prisms have a bunch of rectangles, triangles have a bunch of pyramids have a bunch of triangles there. Okay, but you name the first word is whatever the base is, and then you either say pyramid or prism. Okay, the big ones that are not polyhedrons, and hopefully you can see the trend here. These are not polyhedrons. Just like when we did not have polygons, something cannot be a polygon if it has a curved edge. So things cannot be polyhedrons if they have curved edges as well. I think I might have said that wrong. Polygons and polyhedrons can't have curved edges. So if we have two circles on the bottom with a curved edge around it, that's a cylinder. Okay, we have one right here that looks just like an ice cream cone, right? It's tempting to want to call this a pyramid, but it has a circular base where we need the base to be a polygon for us. And then something that looks like a ball the formal name is a sphere. Okay, so here's some more examples. Hopefully you can see the difference between the prism and the pyramid. Okay, all of these prisms have some sort of base. So the triangular prism, the base would be this triangle here. Okay, a rectangular prism has a rectangular base. So they're all rectangles. That's easy. And then we already kind of talked about the pentagonal prism. All the pyramids, notice they have just a bunch of a bunch of triangles. So they could have a triangular base. They might have something different, like this one has a rectangular base or a square base, pentagonal. The one trick too is that a pyramid, depending on what the base is, will dictate how many triangles there are, right? Like a pentagonal pyramid will have 5 triangles coming to the point. Okay, so let's do some examples. So for example 1, we have to first determine whether each solid is a polyhedron. So for A, we have to look for it. Does it have any curved edges? If it has curved edges, not a polyhedron. If it's all straight edges, then it can be. So this is just a bunch of rectangles all put together. So we can say, yep, this is a polyhedron. Check. Then it says identify the solid. So we know that if it has a bunch of rectangles, then it's going to be a prism. Okay? Specifically, whatever the base is the type of prism. So this is a whole bunch of rectangles. So we'll just deem what the bottom and the top of it, like if this was a box, those are the bases. So this is going to be a rectangular prism. Okay, and then if it is a polyhedron, name the bases, faces, edges, and vertices. Okay, so the bases are going to be the top and the bottom. So when we name any shape, we need to start at a corner and rotate around. We don't get to just jump around. We can start at any corner. We can rotate clockwise or counterclockwise, but we can't go like diagonally across. So if we were going to name this bottom here, okay, you can write out the word rectangle if you want, or you can just draw a little rectangle so that way you don't have to write it out. But you could call this, I'm going to call it M-N-O-P. M-N-O-P. Okay, in a prism we always have two bases, so we also have to say the top up here. Okay, I'm going to again draw my little rectangle so I don't have to write out the word, but R-S-T-Q. If you started at a different letter to name that, that's okay. If you rotated counterclockwise, that's okay too. Just make sure you didn't go from like R to T or Q to S. That's not allowed. We also have to name the faces. Okay, so those are the rest of the rectangles. So the one thing is that all bases are faces technically. So we can already name the top and the bottom. Oh, wow, I did not name that correctly. So M-N-O-P, R-S-T-Q. So those are both there. So we did the top and the bottom. So let's do this side out here. I'll just call that what? Q-T-O-P. And then we'll just do the other side. Lots of things to name. R, S, and M. Alright, and then we'll do this like front piece here. Again, pick a letter, rotate around. R, Q, P, M. And then this back one. We can call that S-T-O-N. Okay, so those are the polygons that get put together to create our three-dimensional shape. Then we also have to do the edges. So these are more like the segments that are created. So remember when we name segments, we have to name them with two letters. But these are where the two planes come together. Okay, they make like the edge of your table. So we could start here. We could call this either QT or TQ. And we can just start moving down. TO, move across. QP. Oh wait, I skipped one. OP I meant. And then PQ. Again, we can say PQ, QP. Then I'm going to move to the left. I'll go just RM. The order that you even list these in also does not matter. This one has a lot of edges just because it has a four-sided shape that is being put together. RQ. MP. I like to trace over them or at least mark them in some way so you don't accidentally name them twice as well. So RS, going down, SN, across, MN, and then the back to ST, and NQ. And oh, what am I saying? There we go. So there's all your edges, okay? And then the vertices are all the corners, okay? So where you have three or more faces coming together to create that corner. So sometimes if it's easier, you can put them in alphabetical order because they're just really points. We don't have to worry about rotating in any sort of way. We just have to make sure we put commas or we're distinguishing that they're different. So if you want to put them in alphabetical order to help yourself, you don't have to. We could just say R, M, and if you want to mark them off as you're listing them, S and N, Q and P, and T and O. But those are basically the points, so only one letter to name those right there. Okay, and just for fun, let's do the next one. So it says we have to determine if it's a polyhedron. This one is not a polyhedron. Whoa, I don't know why that keeps happening. Not a polyhedron because it has curved edges, right? And if we have to name it, does it say name it? Yes, identify the solid. This is a cylinder. All right, let's keep moving. So we do have some regular polyhedrons. Those are made up when we have regular polygons put together. The one you hopefully notice is the cube, right? A cube is made up of 4 squares, and squares are regular. I am not going to ask you to memorize these. I just saw that they were in there, and I thought you might like to see some nice regular shapes, okay? Okay, so let's talk about surface area and volume. Okay, so your surface area is the 2-dimensional measurement of the surface of the solid. So basically, if we found the area of all the planes that make up the shape, okay? The volume is the amount of space enclosed by the figure. So like if you had a box, how much can you actually fit in the box? Or if you had a cylinder, right? Like if we have a can of pop, how much liquid can we actually fit inside of the cylinder would be the volume. So again, the surface areas are not on the reference sheet. The volumes are, okay? But my biggest piece of advice is make sure you're looking at what the variables actually stand for. The biggest one that people mess up is this capital B down here, because we've seen a B when we find like the area of a rectangle or the area of a triangle, right? We usually see a lowercase b as base, but the capital B means area of the base. So super important that we don't get those confused. Just make sure you're reading it very carefully. Okay, so if we do an example like this, oh, the other thing I wanted to show you is that if we're talking about perimeter, this is just going to be whatever the units are that we have. So like if it's centimeters, it's just going to be centimeters. Our area or our surface area, anything to do with area, is going to be your units squared. So this would be like centimeters squared. And then volume is units cubed. So our centimeters cubed. All right, so find the surface area and volume of the square pyramid. So we can look up ahead if we want. Okay, what we could do too is we could just break up the surface area into the different pieces. Okay, this is a square pyramid, so the base, these are all 6s because they're squares, okay? So if we want to find the surface area, we could use the equation above, or we could break it down into the 2-dimensional shapes that we know. So we'd have the square base, which hopefully you remember the square area of a square is length times width or base times height. So that would be just 6 times 6. Okay, and if this is a square pyramid, we have 4 triangles coming up to touch the point. Okay, so we want to do 4 because this is going to be all 4 triangles have the same area. And then to find the area of a triangle, it's 1/2 the base of the triangle, which is 6, times the height of the triangle, which is 5. Okay, so 6 times 6 would be 36. 6 times 5 is 30. Half of 30 is 15. Times 4 is not 90, 60. Okay, and then add those together. 36 plus 60 would be 96, and our units would be centimeters squared. For volume, you're definitely going to want to look at the equation. I don't know what the equation is off the top of my head. For a pyramid is 1/3 capital B H. And remember that capital B, this is looking for the area of the base. Okay, so 1/3 the area of the base. Remember we said that that was the square, length times width, or 6 times 6, times the height of the pyramid, which was 4. I'm going to go ahead and put that in my calculator. 1/3 times 6 times 6 times 4. And remember, we can also multiply in any order, so it's okay if you switched up. And this would be centimeters cubed. Okay, so let's go ahead and leave those next. So I think you kind of get the idea. Just kind of figuring out which equation you're going to use and then plugging in your values. Let's see what else we got. Okay, so let's go ahead and stop there. Thank you for watching, and that is step 3.